Okay, in the last lecture we have got the equation which was rho 0 L dash by S d2 zeta by dt square plus rho 0 c k square upon 2 pi d zeta by dt plus rho 0 c square by v zeta is equal to p to the power I omega t. Okay, only one thing I need to verify, which is the value of the pressure, okay, which was here I should have made a small s, okay, which was the condensation value I told you over here dV by V. So that is taken care, but here only by mistake I put a capital S, so that should be small s. So this small s is dV by V, okay, this dV by V from here, and this dV is S zeta, which is come over here, okay, into V. Further what I did, then again take the equation of F. So P is now rho 0 c square S zeta by V into S. So we got this effective stiffness constant. Done? Okay. So what we have got the value now? We got the value rho 0 L dash by S. Okay. And then I said this, after dividing the S square, we have got M to be rho 0 L dash by S. So how will I write the equation now? I will write the further equation to be M, because I am replacing rho 0 L dash by S, rho 0 L dash by S by M. So M d2 zeta by dt square plus, okay, as I mentioned, the middle term will be called as R. Rho 0 c k square by 2 pi is R d zeta by dt plus rho 0 c square, okay, to which I am calling it as zeta by c, okay, is equal to p e to the power I omega t. Now this is my equation for the acoustical system, okay, and as we are trying to say that we have the three things together, okay, which three? One is the mechanical system. So here we have M, which is mass, okay, K is the restoring constant, this is the damping constant. In case of electrical system, we had L d2q by dt square. L was the inductance, R was the resistance, and C was the capacitance. Okay, so X was displacement, 1 upon C was the capacitor, and in this case, this 1 upon C term we have to define now. So here I have three terms. One is M. M is what now? M is rho 0 L dash by S. Okay. Next is R. What is R? Rho 0 c k square divided by 2 pi. And the next term should be this. So what I said, that the value of C, okay, will be V divided by rho 0 c square. Okay, because we are writing zeta by C only. Okay, so anyway, so obviously the meaning will be similar. Now we need to define this, that how these three things are analogous, like M analogous to L analogous to capital M, R, but the meaning is different. Here we have the value of K, restoring force constant, then this is 1 upon C, and here it is also 1 upon C, but the meaning again is different. Okay, so that's the reason we will try and define the three things, which is M, R and C. Okay, so what is M first? We will say it is acoustic inheritance. M is acoustic inheritance. So now we have to define that acoustic inheritance and also write down the equation, the unit. Okay, so this capital M, which is acoustic inheritance, basically is defined as small m divided by S square. Now what is small m? This was my small m. Rho 0 L dash S divided by S square. Rho 0 L dash S divided by S square, cancel one S, you get rho 0 L dash by S. So this is my capital M. Okay, so this capital M, which is the acoustic inheritance, okay, which is given by rho 0 L dash by S, and we need to know the unit now. And this is what I said earlier, it is analogous to the electrical inductance and mass of the mechanical system. Okay, now to find out the unit, what will I do? I will just check the unit for rho 0. Rho 0 is density, should be kg per meter cube. Okay, L dash will be meter, and what is the unit for this S will be meter square. Okay, so what you can cancel, so 1 meter gets cancelled and you have kg per meter raised to 4 is the unit for this M, which is acoustic inheritance, which is small m by S square. And what is small m? The small m is the effective mass. Fine, here I wrote small m. Yeah, this was my rho 0 SL dash, this was my small m. Done. Now we'll go to the second one. What is the second definition? Is the capital R. What is capital R? Capital R will be my acoustic resistance. Acoustic resistance, which is analogous to what? Analogous to the electrical resistance and the damping constant for the mechanical system. Okay, so what is the formula for this rho 0? Rho 0 is basically R is basically rho 0 C K square divided by 2 pi. Okay, and how we got the value here? Rho 0 C K square by 2 pi. Here what we did here, already we took this term in short directly. We didn't did much of derivation part for this term itself, but remaining obviously we did it. Okay, so now this type of any type of acoustic element basically or characteristic, okay, that leads to the dissipation of energy is analogous to the electrical resistance. Okay, that's what a definition we can say, that any type of acoustic element or characteristic that leads to dissipation of energy is analogous to electrical resistance. Okay, and the value of R is rho 0 C square by C K square by 2 pi, and the unit now. Okay, how we will get the unit now? In this case again similar, rho 0 will be kg per meter cube. Okay, C is velocity or the speed of sound, so meters per second. Okay, then 2 pi no unit, and K square will be 1 upon m square. Okay, so from that we will get the value, 1 m gets cancelled obviously, and you have kg per meter raised to 4 second. This is meter per second. Okay, so kg meter raised to 4 second is the unit of acoustic resistance. Now we'll go to the third term. After doing this, the third term is C. Now what is C? Basically C is called as the acoustic compliance, very important term. Acoustic compliance, C-O-M-P-L-A, acoustic, C-O-M-P-L-I-A-N-C-E, acoustic, P-L-I-A-N-C-E, which is denoted by capital C basically. Okay, so acoustic compliance is given by what? C is equal to V divided by rho 0 C square. Now from that, what will I get the unit? C is V by rho 0 C square. Okay, now what is my V? V is the volume, so MQ. Okay, MQ. Then rho 0 will be as usual kg per meter cube. Okay, and C square will be meters per second ka square. Okay, so if you simplify this, what will I get? Okay, this is meter cube, this meter square gets cancelled, so 1 meter is left, that goes up, becomes meter raised to 4. Okay, second square will obviously go up and divided by kg. Okay, this second square will go up, this m square will, only 1 m will remain, goes over here, meter cube. Okay, so this is the unit for my acoustic compliance. Okay, now this acoustic compliance basically is defined as, now we will just say a definition, like I said, a definition of resistance, that the volume displacement, okay, that is produced by the application of unit pressure. Okay, volume displacement that is produced by the application of unit pressure, and which is analogous to what now? We are seeing now three terms, which is analogous to the electrical capacitance. Here I said 1 by C, okay, and in this case is a force constant. Clear? So unit already I mentioned is meter raised to 4 second square divided by kg. Okay, now what is left is the comparison. Okay, so next part will be the comparison. So we'll try and draw the diagram for all these three things together. Okay, so how will we do that? We will just do in a table form. Okay, so the table form I will just show you how you are supposed to do. So I just show a paper over here. This is my analogies between acoustical, mechanical and electrical. Okay, so this is my acoustical system, electrical system, mechanical system. Mechanical system, as I mentioned earlier, I just showed you the mass which was shown over here. This mass, okay, attached to a spring. Okay, so that mass is over here, L is over here. Now see this system, M, L and this capital M. So acoustical, electrical, mechanical. So this M which I defined just now, what was M? Rho 0 L dash by S is shown in this fashion called as inertance. Acoustic inertance is shown in this fashion. Inductance is inductance and mass is the mass. So this is the way we are doing the analogy. Second one is what? Second one is the compliance in case of acoustical system, capacitance in case of electrical system, and compliance in the case of mechanical system itself. Okay, is called as 1 upon S. Okay, this C is V by rho 0 C square, compliance. Now the last one is R, acoustic resistance, which is shown in this fashion for acoustic system. Electrical system is just normal R, and mechanical system is this way, Rm. Okay, so this is called as, in short, the comparison between the acoustical system, mechanical system and electrical system. You need to know these symbols very well. These are obviously, we know it, LCR circuit, this spring attached to a block, okay, of mass M. Okay, so all these are known to you. Only these symbols you need to know: inertance, compliance and the resistance. Okay, which is called as acoustic resistance. Done? Okay. The next topic will be schematic representation of Helmholtz resonator. Now we have seen how the Helmholtz resonator was shown or taught to you. Now this we are trying to change in a pattern which is like this. Just now we defined these three definitions, M, C, R. So this is my M, capital M, okay, which is the acoustic inertance. Okay, R is the acoustic resistance. See the symbol, acoustic resistance. Okay, M is over here. M is this part, and then C. Now, what I showed here, I had equivalent circuit obviously. So LCR in series connected to the AC voltage. So the resonance will happen when resonance of the Helmholtz resonator is XL minus XC is equal to 0. Right? So what is XL? Is the inductive reactance. What is XC? Capacitive reactance. Okay. So when this XL minus XC is 0, then you get the resonance in the circuit. Okay. So we need to know the equation now. So XL is omega 0 M minus 1 upon omega 0 C is equal to 0. So if you cross multiply, we get omega 0 square mc minus 1 is 0. So which means omega 0 square is 1 upon mc, or omega 0 is, I can write over here, omega 0 is under root 1 upon mc. Substitute the value of m and c, which you have just learned. What is value of m? We have learned m is rho 0 L dash by s. So rho 0 L dash by s is the m value. Here I have put a square. And what is c? C is v by rho 0 c square. Cancel rho 0, you get the value of rho 0 square to be s c square by L dash v. So therefore rho 0 is c under root s by L dash v. This is the value of the frequency. Done? So I think with this the second module comes to an end. The value of, after knowing the value of rho 0, okay, you got the value exactly of c times under root s by L dash v. Obviously problems are there, okay, so we'll take the problems also. I'll solve that, but in the examination we'll take the syllabus till this expression. Problems on Helmholtz resonator are little lengthier, so I will not add in this test. I'll add it in the second test. Okay, so do well. Any difficulty, feel free to ask. Okay, and see to it that you watch the video in 48 hours, and don't forget to write your name for attendance. This is the last time I am repeating it. Okay, so